Hello and welcome. In this lesson we're tackling one of the most important topics in IGCSE physics, Newton's laws of motion, part of the forces and motion unit. Legend has it that Isaac Newton was inspired by a falling apple. By the end of this video, that same idea, that forces cause motion, will let you understand everything from a book resting on a table to a rocket blasting into space. Let's begin. Before we dive in, here's what you'll be able to do by the end of this lesson. First, define a force and give its unit, the Newton. Second, draw and label a free body diagram. Third, state and apply all three of Newton's laws. Fourth, use the equation F equals ma to solve numerical problems. And finally, tell the difference between mass and weight, a favorite of the examiners. Keep these in mind as we go. So, what actually is a force? Put simply, a force is a push or a pull acting on an object. We measure force in newtons, with the symbol capital N. Crucially, force is a vector quantity, it has both a size and a direction. That's why we always draw forces as arrows. The length of the arrow shows how big the force is, and the way it points shows its direction. Get comfortable with arrows, because we'll use them on every slide from here on. There are lots of different forces you'll meet, but they're all still just pushes or pulls. Here are the 6 you need for IGCSE. Weight pulls everything down towards the earth. The normal, or reaction force, is the support a surface pushes backward. Friction opposes motion between surfaces that are sliding. Air resistance, a type of drag, opposes objects moving through the air. Tension is the pull in a stretched rope or string. And the driving force is what pushes a car or engine forwards. Learn the names, examiners expect the correct term. A free body diagram shows just one object with all the forces acting on it, drawn as arrows. Here's a box sitting on a table while being pushed. There are 4 forces. Weight, W, acts downwards. The normal reaction, R, from the table acts upwards. The applied force pushes to the right, and friction acts to the left, opposing that push. Notice each arrow starts at the object and points in the direction the force acts. Being able to draw one of these cleanly is the first step in almost every forces question. When several forces act on an object, we combine them into a single resultant force. If the forces cancel out, the resultant is 0. We say the forces are balanced, and the object either stays still or keeps moving at a constant velocity. If they don't cancel, there's a non-zero resultant, the forces are unbalanced, and the object accelerates in the direction of that resultant. This single idea, resultant force, is the bridge to Newton's first 2 laws. Newton's first law, an object will stay at rest, or keep moving at a constant velocity, unless a resultant force acts on it. This resistance to a change in motion is called inertia, and the more mass an object has, the more inertia it has. So an object doesn't need a force to keep moving. It needs a force to speed up, slow down, or change direction. If nothing pushes or pulls overall, its motion simply doesn't change. Let's make the first law real. Think about a seatbelt. When a car stops suddenly, your body wants to carry on moving forwards at the same speed. That's inertia, and the seatbelt provides the backward force that stops you. Or a book resting on a table. Its weight is balanced by the table's reaction force, so the resultant is 0 and it stays put. Both are the first law in everyday life. No resultant force means no change in motion. Newton's second law tells us what a resultant force actually does. It makes an object accelerate. The bigger the force, the bigger the acceleration, the bigger the mass, the smaller the acceleration. We write it as force equals mass times acceleration, F equals ma. Watch the units, force in newtons, mass in kilograms, acceleration in meters per second squared. In fact, 1 Newton is defined as the force needed to accelerate 1 kilogram at 1 meter per second squared. Let's put the second law to work. A car with a mass of 1,000 kilograms experiences a resultant force of 2,000 newtons. What is its acceleration? Start by writing what we want, acceleration, so we use equals F over m. Substitute the numbers, 2,000 newtons divided by 1,000 kilograms. That gives an acceleration of 2 meters per second squared. Always show the equation, the substitution, and the answer with its unit. That's how you pick up full marks. Rearranging F equals ma is made easy with the formula triangle. Put F on the top, and m in the side by side underneath. To find any quantity, cover it up with your finger. Cover F and you're left with m times a. Cover m and you get F over a. Cover a and you get F over m. 3 equations from one triangle, F equals ma, mass equals F over a, and acceleration equals F over m. Use it whenever you're unsure which way round the formula goes. The second law also tells us how acceleration depends on force and mass, and graphs make this clear. On the left, with mass kept constant, acceleration is directly proportional to the resultant force. Double the force, double the acceleration, so the graph is a straight line through the origin. On the right, with force kept constant, acceleration is inversely proportional to mass. Double the mass, halve the acceleration, giving a curve that falls away. Directly proportional to force, inversely proportional to mass. Newton's third law: for every action there is an equal and opposite reaction. If object A pushes on object B, then B pushes back on A with a force that is equal in size but opposite in direction. The most important point for the exam, and the one students most often miss, is that the two forces act on different objects. That's why they never cancel out. Same size, opposite direction, different objects. Say it like a mantra. The third law is everywhere once you look. A rocket pushes hot gas downwards, and the gas pushes the rocket upwards. That's thrust. A swimmer pushes the water backwards with their hands, and the water pushes the swimmer forwards. And when you walk, your foot pushes back on the ground, and the ground pushes you forwards. In each case there are two forces, equal and opposite, acting on two different objects. Motion in one direction always comes from a push in the other. Here's the classic trap. A book rests on a table. Its weight pulls it down, and the table's normal reaction pushes it up. These two forces are equal and opposite, so are they a third law pair? No, they act on the same object, the book, so they're a first law balanced pair, not an action-reaction pair. The true third law partner of the book's weight is the book's gravitational pull on the earth. The real partner of the table's push is the book pushing down on the table. Third law pairs always act on different objects. Mass and weight are not the same thing, and examiners love to test this. Mass is the amount of matter in an object, measured in kilograms. It's a scalar and it never changes, wherever you are in the universe. Weight is the force of gravity on that mass, measured in newtons. It's a vector, and it does change depending on the gravitational field strength. We link them with W equals mg, where g, the gravitational field strength on Earth, is about 9.8 newtons per kilogram. So a 1 kilogram bag has a weight of roughly 9.8 newtons here on Earth. Free fall and terminal velocity bring the laws together beautifully. When a skydiver first jumps, weight acts down and there's almost no air resistance, so the resultant force is large and they accelerate. As they speed up, air resistance grows. Eventually air resistance grows until it exactly equals their weight. Now the resultant force is zero, so by the first law there's no more acceleration. They fall at a steady, maximum speed we call terminal velocity. Open a parachute and air resistance suddenly increases, they decelerate, and settle to a new, lower terminal velocity. Before we recap, here's how to attack any forces question in the exam. Step 1. Draw a free body diagram and mark on every force. Step 2. Find the resultant force first, add forces in the same direction, subtract opposing ones. Step 3. Only then rearrange F equals ma for the quantity you want. And step 4, the easy marks. Always include the correct units and, if asked, the direction. Follow these 4 steps every time and you'll rarely go wrong. Let's bring it all together. The first law, an object stays at rest or moves at constant velocity unless a resultant force acts, that's inertia. The second law, a resultant force causes acceleration, given by F equals ma. And the third law, every action has an equal and opposite reaction, acting on a different object. If you remember these 3 sentences, you've got the backbone of the whole topic. And that's Newton's laws of motion. Thanks so much for watching. If this helped, please hit subscribe and ring the bell so you don't miss the next lesson. When you're ready, take the quiz in the link below to test yourself. See you in the next video. Good luck with your revision.